I'll give the presentation as Dr. Asya presented the work with her PhD student. This is work of my master student, Baraa Abu-Znead, for her energy renewable program. You know, to simplify things, we add various chemicals, various materials to concrete in order to change the characteristics, to manipulate the characteristics for obtaining a required performance. Just how to step down. Okay. But it's not moving. Okay. Okay, good. Concrete is a composite material that includes, in addition to the cement, sand, aggregates, some additives and admixtures. In this study, we consider to take the ceramic waste and grind it, then add it to the concrete mixture so that we can manipulate its thermal characteristics. Many studies had investigated various types of additives for concrete in order to manipulate, for example, mechanical properties, durability properties. Some of them has tried the ceramic particles as an additive, as a replacement of sand. Here in this study, we added the ceramic particles as a replacement of cement to see how it affects the properties. So the problem is to investigate the utilization of these waste for waste recycling purpose, which is an environmental purpose, and for energy management by enhancing the insulation characteristics of concrete. Simply, we added 5%, 10%, 15%, 20% of the cement weight in the concrete mixture to see how the concrete thermal characteristics are impacted and how the mechanical characteristics of fresh and hardened concrete are impacted. So the materials included the typical concrete materials. In addition to the ceramic waste, we obtained them from local ceramic factory in my Hebron, in my old town, which is Hebron in Palestine, which is famous in manufacturing ceramic stuff. Then after grinding the ceramic particles to the required particle size mentioned here, according to the sieve number 40, then we casted the concrete samples with the various percentage addition I already mentioned. These are the types of mixed designs that we investigated. As you see, here we have the codes for the samples, and the second column, we have the required percentages for replacing the cement. In the first column, in the first row, we have the control sample. Then the cement mass was reduced by a fraction of 5–10%, for which the ceramic particles, which are the last column, are added to replace the cement to see how we can impact the characteristics. Then, after having the concrete cured for 28 days, we measure the thermal conductivity according to the well-known Fick's law for steady-state conduction, and we measure the specific heat from the mass balance by immersing the concrete sample in a bath of water with in an insulated vessel. When they reach equilibrium, we know we could calculate the specific heat from a well-known heat balance equation for sensibility. Then for the results, this is the main curve that we obtained for the various percentages. For example, thermal conductivity for the typical design, the typical concrete design, we have this high value, and then by adding 5%, it is reduced. 10% is reduced. At 15%, it almost maintained at 10 or slightly higher, but then at 20% reduced more. So this curve shows us that adding ceramic particles as a cement replacement can reduce the thermal conductivity, which means it enhances the thermal insulation of concrete so that the heat loss to the surrounding in the winter we can make the house more warm, and in the summer we can make it more comfortable by allowing less heat coming from the outside. Now, for investigating the other characteristics, for example, the specific heat, we had different trends. The control sample had low specific heat. You know, the specific heat is how much the concrete can store energy. This is good also in heat management or energy management of the building. When we added the 5 and 10%, we had a slight increase, but then for 15%, we go back to almost the control value or slightly above, and the same way for the 20% addition. Now, we had to also to check how the addition of ceramic particles affects its mechanical properties, because we want concrete walls to withstand the stresses on it. First of all, we had to test how the strength development with age from the day of casting. As you see, we had the control sample and the slightly modified sample. Why this is a typical curve for 10% addition. We have like at the early ages they go together, but at the late ages we have a small reduction in the compressive strength, as seen. Typically in concrete, we consider the 28 days compressive strength. As you see, the 28 compressive strength for all percentage addition, there is a slight reduction in the compressive strength, but still it's manageable. For example, the control sample has a compressive strength of about 24 megapascal. The 5% addition is about 23. So it's a minor reduction, manageable reduction, and this means that we can enhance the thermal characteristics while maintaining most of the required strength. Then we had investigated the effect on other characteristics. For example, the density. Adding the ceramic particles reduces the density of concrete in most of the cases, except at the 20%. While the water absorption, which is also an important characteristics for the durability of concrete, when we add the ceramic particles, the density at 5% is nearly reduced or maintained close, but then the water absorption increases because we have large particles for ceramic particles. Maybe in future we can reduce them more, because we don't want the concrete to absorb water because it affects its durability, as I mentioned. Now, the slum is how fluid the concrete mixture at early stage. Slum is needed in many applications. As you see, we had like some reduction with the slum by adding the ceramic particles. This depends on the type of application for concrete in order to evaluate whether this is like an important issue or can be managed, depend on the application of the system. Finally, the major conclusions of our study, and I appreciate the work of my master student. Crushed ceramic waste particles can be successfully added to concrete as a partial replacement of cement to improve its thermal characteristics, which is the main target of this work. The thermal conductivity decreases with increasing the percentage of the addition. The specific heat increases till 10%, then decreases. This waste management approach leads to better energy saving in buildings from one side, as well as better concrete durability against thermal attack from concrete under freeze and thawing cycles. You know, in severe cold conditions, the concrete gets to low temperature, then under the thawing cycle, it gets hot. This thermal changes affect the concrete. When the thermal conductivity is reduced and the thermal insulation is enhanced, the effect of these cycles will improve the durability and the sustainability of the structures. These achievements are associated with impacts on mechanical and physical characteristics that require further attention and further research. I try to stick to the time,
yes, thank you so
and
much
that's
for your time and your interest subject. If you have any questions, you can ask. Yes.